Welcome to a new video. Today we are going to discuss about double linked list. Double linked list is a linear data structure in which every node in the double linked list have minimum three partitions. First one is the left address field, next one is the data field, and third one is the right address field. Left address field represents the address of the previous element or previous node. Right address field represents the address of the next node, and data field contains the data that we are storing in the node. This is the example diagram. Here 10, 20, 30, 40, 50. These are the elements that we have, and 10 is the head node and 50 is the last node. Head node's left address field will be null. Last node's right address field will be null. Head node's left address field will be null because there is no previous element. Last node right address field will be null because there is no further element or following elements. Okay, so this is a concept. Right address field of 10 is 200 because the next node address is 200. 20 is having left address field and right address field. Left address field contains address of 10. Right address field contains address of 30. And node 30 has a left address field, and the left address field contains address of 20. Right address field contains address of 40. And in the case of a node 40, left address field contains address of 30. Right address field contains address of 50. And node 50, the left address field contains address of 400. Left address field contains address of 40, and 50 is the last element. Right address field will be null. So this is a list of elements that we are having in the example. Okay. So how the structure of this program will be? Here we have three partitions, one data and another two address partitions are there. So I am modifying the structure from single linked list. So in data, that is same. Here a struct node is a self-referential structure. So struct node star left and star right. So left represents the left address field, right represents the right address field. I am using the same pointer variables like star head, star q, and star p. So this is the structure of a double linked list. So what is the difference between single linked list and double linked list? In single linked list we can travel from head node to the last node. There is no point of traveling from last to the previous node, or in the reverse direction. Only one way direction or a forward direction is only possible there in the single linked list. But in our case, we have a double linked list having two address field, left address field and right address field. So the advantage is if you are traveling from 10 to 20, 20 to 30, and if you wish to travel from 30 to 20, it's possible because we have a reverse link. We have a left address field. But in a single linked list, we don't have any left address field. So once we travel from head node to the last node, again if you want to go to the intermediate node, then again we have to travel from first node to that particular node. So the traversal time is too high in single linked list. In double linked list, we can reduce the traveling time or a searching time. Traveling time in the sense searching time. For example, in single linked list, if you want to search an element from for example, I want to search in the first search. First time, if I want to search 50, we will start our searching from head node to the last node, and we will identify the element. Okay. So right now we are in 50. Immediately, next search option is, for example, the next element we want to search is 30. So what we have to do? We can travel in the reverse direction. So 50, then 40, verify whether 40 equal to 30. Okay, no. If next we move to the previous element, 30 equal to 30. So here we can travel in both the directions. So because of that, the searching time is getting reduced. But in the case of a single linked list, we don't have an option like that. In single linked list, here only one way direction is possible. So if you are traveling from head node, for example, if we want to search of element 40, what we will do, we will start from head node. Okay, head node is 10. So compare 10 with 40, condition false, and move to 10 with 20. Sorry, 40 with 20, condition false. Then 40 is 40, condition true. At the next search is consider again we want to search 20. So what we can do is we can travel again from head node to that 20 and then identify the element. But in our case, in a double linked list, we can travel in the reverse direction so that we can reduce the searching time. That is the advantage of single linked list over double linked list. Okay. In this case, we have again insertion, deletion, and display. These are the operations. Then search operation is there. Then count operations are there. So that's our sub operations. But the main operations are insertion, deletion, and display. Insertion, we have three options. First one, insertion at the beginning. Second one, insertion at the end. Third one, insertion in between two elements. In this case, consider these are the list of elements that we have. I am going to insert the element at the beginning. So consider this is a new node that I am going to create. This is a new node that is that we are going to add in the beginning of the node. That means before 10. So what are the changes that we have to make to insert the element? That is the first thing. First step is to add a new element. So for example 60. Okay. This is going to be the first element, so the left address will be null. There is no doubt on that. Okay, then the right address should contain the address of the head 100, and after that already existing head address head's left address field should contain the address of the new element 600. Okay, and after that one more final step is there. You have to make this one as the head node. Okay, make the head address field is equal to 600. Okay, these are the changes that we have to make. So I am going to complete the steps one by one through a program. Okay. Okay. If position, I am not going to explain all those things that we explained in the previous single linked list. I am directly going to the exact points here. If position equal to 1, if position equal to 1, then what we are going to do? We are going to we created a new node. The step is same for for creating the new node. What is the procedure? P is a variable that I am using here to create new element. P equal to ml of size of struct node. We are not going to change the name of the structure, so the syntax is same. Struct node. Okay, a new node is created. Next thing that we can do is we can add the data, because anyway we are going to create a new node, so we can add a data here. P times data equal to element. That also we completed. Then we collected the position, verify whether POS equal to 1. If POS equal to 1, then what we can do is we can directly add P tends to left equal to null. Okay, P tends to right equal to head, because so after the first step 60, after this particular step we added 60. Then position equal to 1, P tends to left equal to null. There is no doubt on that. This is going to be the first element. P tends to right. P tends to right equal to head. Head address field is head contains address. Already existing head address is 100. Okay. Head address is 100, and now what we are doing is P tends to right. P tends to right equal to head equal to 100. Then what's the next step? Head address left field should contains 600. So head tends to left equal to P. Okay, so after this particular statement, this field is accommodated with the new element's address. Then we are assigning the value of head as P. So this is going to be the new head. Okay, so this is the case. So now we have a link like this. Okay. We have a link like this. So this is a insertion part in the beginning of the node. Okay. Okay, before that, one more thing is there. If head equal to null, and what's the meaning of that? The list is empty. If head equal to null, what's the meaning of that is list is empty. If this is the case, that what we are doing going to do is P tends to okay, this is a case that we will add after the statement if head equal to null. Okay, if head equal to null, then what we will do? P tends to left equal to P tends to right equal to null. Okay, that means that particular node's left address and right address will are assigned as null, and this is the only element, and this is going to be the head. So head equal to P. Okay, if this condition is false, else, okay, that means if this condition is false, then only we are moving on to the next case of insertion. Okay, so this is the case. Return. Completed. So insertion at the beginning is over. Okay, next insertion at the end. Insertion at the end, that means you are going to insert the element at the end of the node, end of the list. Okay, so if so, so here we are incrementing after each and every insertion, we are updating the value of count plus plus. Okay, here also I am using the same. Now we can make this one common. Anyway, we are going to create a new no. We should not do like that. Okay. Okay, just think of that, why I am not commonly add this count there. Okay. In this case, we are going to explain how to insert the element at the end of the list. If POS equal to count plus 1, if this is the case, if POS equal to count plus 1, what's the meaning? We are going to insert the element at the end of the end of the list. First step is to travel from first node to last node. So Q equal to head. Next step is traveling from head node to the last node. How will we do? While Q tends to right not equal to null, the same. If this condition is true, we will move Q equal to Q tends to right. Okay. So once this is a procedure. So Q is initially 100. Q tends to right is equal to 200 not equal to null, condition true. Q equal to Q tends to right. So Q is equal to 200 tends to right, again 300. 300 not equal to null, so likewise we travel up to 500. Once we reach 500, then what's the next step? We can directly say that p tends to right equal to null, because this is the last element. Okay, we don't have any other option, so the new node's right address field is null. Then data field already we fill, for example 60. Okay, what should be here? Okay, p tends to left, we can directly add. Very simple. These are very simple examples. P tends to left equal to what? Q. Okay, Q is now 500, so 500, one link is created. Then very simple, Q tends to right equal to P. Very simple. So Q is 500, 500 tends to right equal to P, that is 600. What's the meaning of this? Okay, we did this. So we have completed the insertion at the end of the list. Okay, insertion in between, this is the next option. So here if condition is if POS greater than 1 and POS less than count. If this is a condition, then we are going to write a program for this. Okay. If this is the case, then for example, I am going to insert the element in the 4th position. That means in between 30 and 40, 400. So these are the this is the position, 4th position. So what's the next step? We are traveling from head node to last node, so Q equal to head. Okay, Q equal to head. Very simple. We are traveling from first node to last node for I equal to 1, I less than position minus 1, I plus plus. Very simple, that we already studied. Then Q equal to Q tends to right. Okay, Q equal to 100, 100 equal to 100 tends to right, that is 200. Then again initially I equal to, this is for I am ready to explain once again, because this is little bit complicated for some students, so I am explaining the same. Here the position is position equal to 4, I value equal to 1, comma. If this is the case, position is equal to 4, for 1 less than 4 minus 1, 3, condition true. If so, then I equal to I is increment. So here we have initially okay, Q equal to initially 100. Okay, I equal to 1, condition true, 1 less than the position 4 minus 1, 3, condition true. Q is reassigned as Q equal to 200. Q tends to next right. Next again I is incremented by 1, so I equal to 2, 2 less than 3, condition true. So Q is equal to Q tends to next 300. Again I value equal to 3. 3 less than 4 minus 1, 3 condition false. So Q is in the right position. That is the position that we are expecting for Q. So Q is in 300. Next, once we reached here, what is the next step? We are going to fill the portions in address fields of P. P tends to left equal to what? Q. So P tends to left equal to Q. So for example, the data that we inserted is 60, okay, that we completed. P tends to left equal to Q. Q is now 300. So P tends to left equal to Q, okay. Then P tends to right equal to what? This is P. P tends to right equal to what? 400. But 400 is available in the right address field of 30. So right address field of 300 equal to Q tends to right. P tends to right equal to Q tends to right. That means 400. Okay. We created a new node and node's address field and data fields are filled. Okay. Now this node is ready. Next, what we are going to do is we are going to make the changes on this place. Okay. Okay. First step is to make the changes in the next address, next node. That means 40. 40's left address field should be what? 600. How will we access 40? So, listen carefully. Q tends to right. This is very simple. P tends to right. That is what? 400. 400's left equal to P. Very simple. P tends to we are going to make the changes on 40's left address field. 40's left address field should be what? 600. But we have the access only up to 300 because we traveled up to 300. So what we have to do is we have to access the right address because we didn't made any changes here. If we made any changes here, then we can't access this one because the link will not be available. So what I did is before making the changes here, I am trying to make the changes on the next node. So that is the left address field of 40 should contain the address of 600, address of 60. So what I am doing is I am trying to access this node from this node itself. How will we access? So this node address is represented by the variable Q. Q's right address field represents the address of 40. So Q's right tends to left. We are going to make the changes on this particular address field. So how can we access? First we should get the access of this 40. So how will we get the access? Q tends to right. That is the address of this one. Q tends to right, tends to left. So we will get the access or we will get this particular position. Q tends to right, tends to left, which equal to what? The new address, that is 600, that is available in P. So 600. Okay, we made a changes like that. That means this address connection, we cancel that connection, and what we did is a new connection is established. This connection already established, and one more connection is also established here. Okay, then what is next? We have to make the changes on this one. How will we do? Q tends to right equal to P. Q tends to right equal to what? 600. That means a connection is established from this particular node to this particular node. Okay, and similarly we will get a reverse connection also, because this is a double linked list, so a reverse connection is here. Okay, so this is a way that we can insert the element in the middle, in between two elements. Just count plus plus. So we have completed. We have completed the insertion in the beginning, in the end, and in the middle. Hope you understand. And you are going to write the program. You are going to complete the entire program for a double linked list, as well as you are going to write a program for a deletion also. Deletion also similar. If you have any doubt, you can contact me. Okay, thank you.